Hello, welcome to Apsana classes. Today in this video, let's know about the time domain equation for the amplitude modulation. Before knowing the time domain equation, let's know what is actually amplitude modulation is called as. So, for example, let me tell you an example. I am sitting in a last bench. So I would like to send some information or message to my friend who is sitting in the first bench. So I wrote that message in a letter and I thrown to the first bench. So it don't go to the first bench directly because the weight of the paper is very less. So it stop in a middle. So if I kept a stone in that paper and I thrown to the first bench, at not maximum, but it will nearly reaches to the first bench. So as the same way, so let me let you think that the weight of the paper is nothing but here your frequency. So the weight means the frequency of the message signal is low. So here your information, this is your information which is having very low frequency. So I would like to weight that message. So I would like to put that message in one weighted paper or something. I would like to increase the weight of that message. It is nothing but the frequency. Here you consider frequency. So I add with the carrier signal. This is the carrier signal. So carrier signal. Okay. Now I would like to mix these both two and then I would like to send so that it can reach us to the person. So the wave that it will be like this. Okay. See here your information. This is the information that you are going to send. Okay. So here this signal is represented as m of t, which is nothing but, what is m of t? am. So in sine, as it is the sinusoidal, I would like to represent the sine wave. So m of t is equal to am, means amplitude of the signal. So this is called a modulating signal or else message signal. This is carrier signal and this is modulated signal. Okay. Now it is represented as am sine omega m of t. Then this is carrier signal which is represented as c of t is equal to ac sine omega ct. Okay, this is angular velocity time. You know the why it is represented as this. And then now I would like to find the equation for this modulator signal, which is our time domain equation of this modulating amplitude modulation. Now see, we know that the equation of time domain in AM signal is Vam of t is equal to amplitude of the signal to sine omega ct. Why ct? Because the highest frequency is of carrier signal, so omega ct. Okay, but we know that this am, the voltage of this, amplitude of this amplitude modulation is AC plus m of t. Why m of t? Because the amplitude is changing in the carrier signal with respect to this modulating signal. So hence you can substitute. So let it be the equation number 1 and this is as equation number 2. Now substituting equation 1 in equation number 3. This will be the 3. Okay. Then see equation number 1, 2 and 3. I am substituting this equation number 1 into 3. Then we get, here I am doing nothing but, so I am replacing m of t to am sine omega mt. That's it. Nothing I am doing other than that. Am sine. For you to understand in a good manner, I am telling you in equation 1, 2, 3. That's it. Don't get confused. Okay then. Now let it be the equation number 4. Equation number 4. Substitute equation number 4 in equation number 2. So this is our fourth and this is our second. Then we get, just I am putting this equation in this. So we get am of t is equal to AC plus am sine omega mt into sine omega ct. Okay. In meanwhile, let me tell you another concept, that is nothing but the modulation index. So modulation index is represented with m and it is nothing but the ratio of maximum amplitude of message signal, that is am, to maximum amplitude of carrier signal, which is AC. Can I write am as MAC? Of course. So let me substitute this am is equal to MC in this equation here. Then we get Vam of t is equal to AC plus MAC sine omega mt into sine omega ct. Sine omega mt into sine omega ct. Okay. Let me simplify. M of t is equal to AC sine omega ct plus MAC sine omega mt into sine omega ct. So if you observe, it is in the form of sin A plus sin B. You know the formula of sin A plus sin B, which is nothing but our half into cos A minus B minus cos A plus B. So if you substitute this equation in here, we get Vam of t is equal to am sin AC sin omega ct Now I would like to change this equation. So not also this here, only this equation. So plus MAC. Okay. Now you have to change this equation to in this form. So you get cos of omega c minus omega m of t minus cos of omega c plus omega m of t. Okay. Again, let me simplify. into half, right? Sorry, into half, whole by half. If we simplify, we get AC sine omega ct plus MAC by 2 cos omega c minus omega m of t minus MAC by 2 cos omega c plus omega m of t. This is t. Okay. Now, let me tell you another simple concept, that is nothing but the frequency spectrum. So, this is our final equation, time domain equation for the amplitude modulation. Okay, this is our final equation. Now, frequency spectrum. How can we draw the frequency spectrum for this? Frequency spectrum. Okay. So here we are having 3 total. This is total carrier signal and having 2 lower and upper sidebands. So this is lower sideband and it is upper sideband. So how can we draw? It is nothing but, if you take the frequency spectrum, we are having 3 frequencies here, right? The frequency of FC minus FM, FC plus FM, right? Sorry, FC minus FM, that is for lower side band, and FM, sorry, FC and FC plus FM, that is our upper side band, and this is for the carrier. So to draw that, we want the amplitude of this FC and this LSB and USB. So what is the amplitude in this FC equation? If you consider here, see, this omega is nothing but 2 pi f, right? 2 pi f. Then what is omega c? It is nothing but 2 pi fc. So in that way, here fc I am taking, here fc minus fm, and here fc plus fm. Okay, simple. Don't get confused for the fc, fm and all. Okay. Now here in the equation of fc, what is the amplitude? So here we are having fc and the amplitude for that is AC, right? So amplitude is AC. Okay. Now for FC minus FM, the amplitude is MAC by 2. MAC by 2. And then here too, FC plus FM, we are having amplitude for MAC by 2. MAC by 2. So the representation of this, the differences between the LSB and USB, plotting the different frequencies of that equation in one graph is nothing but our frequency spectrum. Okay. So this is the frequency spectrum for the time domain equation in the AM. Okay, let me also tell you the small concept, another one, that is the bandwidth. That is bandwidth of AM. What is the bandwidth of the AM? It is nothing but the difference between upper sideband, the frequency difference between the upper sideband and lower sideband. I am telling the frequency differences only. Okay. So frequency differences. So what are the frequency that we are having the USB? In the upper sideband we are having the 2 frequencies, that is FC plus FM. Okay, let you write that here. FC plus FM and another frequencies in LSB. So in LSB, in the lower sideband, this is the lower sideband. Here we are having the frequencies FC minus FM, right? FC minus FM, LSB. Okay. So let me write that Fc minus Fm. Now if you see Fc plus Fm minus Fc plus minus into minus plus, okay, Fm. So this Fc and this Fc plus and minus will be cancelled. So that we are having Fm plus Fm, which is nothing but the 2Fm is our bandwidth of AM. So in this video I have told you about what is amplitude modulation. It is nothing but change of the carrier signal with respect to the modulating signal. Okay. And the equation that we have derived for this modulated signal is nothing but our time domain equation of amplitude modulation. And then after deriving that, I have said the frequency spectrum. It is nothing but drawing the different frequencies of the equation in a same graph is nothing but our frequency spectrum. Okay. Yes, did. And another one, the bandwidth of AM. I hope you are clear with this. Thank you for watching. Please like, share and subscribe.